Hi, this is Alex from devstories.eu. SQLAlchemy, Episode 1 of 7. Have you ever accidentally dropped a table or mangled a query because of a typo in a raw SQL string? String concatenated queries are fragile, hard to maintain, and a security risk. This episode covers the solution, the foundation, what is SQLAlchemy, and the ORM. The core problem developers face when writing database-backed applications is that Python and relational databases think differently. Python uses objects. Objects have state, behavior, and complex relationships. Relational databases use tables, columns, and rows. They rely on primary and foreign keys. Getting a Python object into a database table requires translating its state into a SQL statement. Getting it back requires parsing rows and repopulating a new object. This friction is called the object relational impedance mismatch. Writing raw SQL strings to handle this translation is tedious and error-prone. SQLAlchemy is a Python SQL toolkit designed to solve this exact problem. Unlike some tools that try to hide the database behind a wall of abstraction, SQLAlchemy embraces SQL. It provides a robust Pythonic workflow that generates optimal SQL while keeping you in control. The architecture is split into two distinct parts, the core and the ORM. The SQLAlchemy core is the foundation. It is command-oriented and schema-oriented. This means you work directly with database tables, columns, and rows, but you do it using Python objects instead of raw text strings. If you want to select data, you call a select method. If you want to filter, you chain a where method. This removes the risk of syntax errors from string concatenation and protects against SQL injection. The core is essentially a SQL expression language. The ORM, or Object Relational Mapper, sits on top of the core. While the core is schema-oriented, the ORM is state and domain-oriented. Here is the key insight. With the ORM, you stop thinking about tables and rows and start thinking about your domain model. You define a standard Python class, for example, a user class. You configure the ORM to map this class to a user table in the database and map the class attributes to the table columns. When you query the database using the ORM, you do not get back raw rows of data. You get back fully populated instances of your user class. The ORM handles the translation seamlessly. More importantly, it tracks the state of those objects. If you change a username in Python, the ORM automatically figures out the correct update statements and executes them through the core. You focus on your Python objects, and the ORM handles the database synchronization. The most important thing to remember is that the ORM is not a black box that replaces the core. It is an optional layer built entirely out of core components, allowing you to seamlessly drop down to explicit SQL generation whenever your domain logic requires maximum performance. If you find these episodes helpful and want to support the show, you can search for DevStoriesEU on Patreon. Thanks for spending a few minutes with me. Until next time, take it easy.